Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to look at TopTechBoy's Raspberry Pi class, lesson number 7. If you remember from last week in lesson number 6, we built what is commonly referred to as a momentary circuit, where we press the button down, the light goes on, light stays on until we release, and then the light goes off. This week, we're going to do something that's commonly referred to as a latching circuit. We press the button down and release, light goes on, press the button down and release, and the light goes off. Let's take a look at the hardware, the program, and finally the code. Hardware-wise, we're running the same configuration as lesson number 6. I have my 5 LEDs from lesson 5 that I'm using as my output LEDs. I have my pull up button and my pull down button. And let's take a look at the program itself. I'm going to start it, and we give a little bit of output to say that we're doing something. And when I press and release the button, the light comes on. When I press and release the button, the light goes off. Press and release on, press and release off. Pull down button's not doing anything. I wonder if I hold it. No, nothing there. I wonder if I hold this down and then push the other one, does something happen? Oh, look at that. We're blinking and we are gracefully exiting the program. All right, let's take a look at the code and see what we got going on. So once we start the code, we bring in our pi.gpio. And last week we had some fun with not the metaverse, and that got to be very impractical. But I was wondering about this because typically you'll bring this in as GPIO. Every book, every document, everything out there shows rpi.gpio as GPIO. The problem with that is if you start looking at other people's code, you start to get the impression that there's something special about the word GPIO, that it's like a Python reserved word or something, when it's not. It's just the name of the object that we're importing. So I've decided to go with something descriptive but short. I'm going to call it pi pins. This way I can kind of set it apart and know that it's not a reserved word. It's nothing special in Python. This is just my code. If I see pi pins, I know that's something that I defined. Once again, we have our LED pins, 0 through 4, up, down. We're doing board numbering. I don't remember if I showed this last week, but I saw in another student's video, rather than going through a for loop and writing out the individual values, it's possible with the .setup method to just bring in the array and write it all out as one. So I'm bringing in the full array, writing it as output, bring in the full array, write it false. If you recall, we had a weird problem where sometimes when we run the setup on the output pins, some of the LEDs would go to high. So I wanted to set it to false to make sure that all the LEDs are off after we set them up. And then of course we're just setting up our pull up and pull down pins as in. And then we're printing our message to know that the program is running. Now with a latching circuit, one of the important things is always tracking the state of the LEDs, whether they're true or false, on or off. So the first thing we want to do is we want to set the state to false. Now we head into our while loop. The very first thing we do, so every time we go through this while loop, the very first thing we do is we write the output state. Whether it's true or false, we're constantly writing it. And that value doesn't change unless we interact with the buttons. So I'm going to look for activity on the pull up button, which is this one right here. And the first thing I'm going to do is I'm going to do a 50 millisecond back off. That is the alternative to using a debouncing capacitor. I want to make sure that that button is still being held down. If you're familiar with switch bounce, you kind of get an up, a down, an up, a down, an up, a down within a few milliseconds. So we just want to skip over that. We're going to go 50 milliseconds past that. And now we know that if you're holding the button down, it's always going to be high. Then we go into a while loop. So while we're holding down the button, Remember, false, it's a pull up. So it's going to be true unless we're holding the button down, then it's false. So we will look for false. And we need to do something in our loop. So we're going to set fry the pi to false. We don't want to fry the pi ever. Don't fry the pi. And we're going to do another slight delay of 10 milliseconds. This doesn't really accomplish anything. It's just making sure that there is actual code in the while loop. Once the button is released, so we did the if that the button was pressed, then we did a while the button was held. If we release the button, we are still inside of this if statement. Then what we're going to do is we're going to invert the LED state by saying LED state equals not LED state. So in binary, if my LED state is 0 or off, and I say that the state equals not 0, the state is going to go to 1. If I say that the state is not 1, it's going to go to 0. So regardless of what the state is, this is going to invert it from a 0 to a 1 or a 1 to a 0. And then we go back through the while loop. Notice we're just setting the state. We're not actually writing the value out to the LEDs. We go back through the while loop, and the first thing we do is we write the new state. And of course, all of this happens in milliseconds, so you don't see the time delay, even though, programmatically there is a short time delay, but you don't really see it. So then we added in the extra feature of the pull down button. So instead of doing an if and a while, this time I do a while and an if. So while the pull down button is true, remember the pull up button is true unless it's pressed down, then it's false. Pull down button is false unless pushed down, then it's true. So you have to think about the difference between pull up and pull down. So I do while my pull down button is true. So while I'm holding that down, we're going to run this loop, because as soon as I let it go, we're going to exit this while loop, nothing happens. While that's being held down, if I press the pull up button like that, then we're going to run the exit sequence. Grace will exit, and we're going to do some blinking here. So we're going to do 3 times through the loop, blink them on, half a second, blink them off, half a second, 3 times, 1, 2, 3, to get that kind of little blinky effect you saw at the end. Then we clean up the pins and we gracefully exit the program. So hopefully that made sense. It took me a little bit of thinking through with the while loops and the switches being true or false depending on which one and how long it's held down, etc. And tried to do it as gracefully as possible. So I hope you enjoyed my solution. If you have any thoughts, leave a comment below, and I'll see you next time. For Simply Brian Enterprises, this is Brian. Have a great day.